Hey guys, Jake here coming at you with another math lesson today. Today we're going to continue going through the topics discussed in the Elite Guide to AP Calculus AB. If you want to get yourself a copy of that book, just go ahead and scan the QR code in the upper right hand corner of your screen, or go check out the link down in the description or pinned comment below. But today we're going to continue our discussion about the foundation of differentiation by continuing to discuss the derivatives of certain elementary functions. Today we're going to jump into trig functions specifically and their derivatives. So really, when it comes to the derivative of trig functions, I really want to kind of focus on how to actually remember them, because that, to me, is kind of the hard part. And I think to most people that is the hard part, is just memorizing which derivative goes with which trig function. So that's what we're going to do today. So first of all, let's just go ahead and jump in. We're going to go ahead and start with the derivative of sine and cosine first, because I think those are kind of the easiest in terms of actually logicking your way through those derivatives rather than just straight memorization. Of course, you can totally just memorize it, but there's a little trick that I like to use personally that I think makes it a little bit easier. So in general, you'll notice that the derivative of sine is cosine, the derivative of cosine is something involving sine, right? So you're kind of just alternating back and forth between sine to cosine to sine to cosine. The difference is, of course, the negative sign here. And so what I want to kind of discuss is, you'll find that if you're thinking about the function sine of x, cosine of x, and then negative sine of x and negative cosine of x, you kind of get this little cycle of derivatives, basically, where you kind of go in a cycle of these four, where you go from the derivative of sine being cosine, the derivative of cosine being negative sine. Then if you take the derivative of negative sine, you get negative cosine. And then if you take the derivative of negative cosine, you get positive sine. So you kind of get this cycle, which actually, let me go ahead and, well, we could do it this way. So the derivative of sine gets you to cosine, derivative of cosine gets you to negative sine, derivative of negative sine gets you to negative cosine, the derivative of negative cosine takes you back to positive sine. And then you kind of just go through the circle like that. So the way that I like to remember this is just very quickly think about what the graph of sine and cosine look like. You don't need to worry, too much about the specifics, the details, but just briefly, if we think about the graph of sine of x, we have our xy axis. Sine of x at the origin, it starts at 0 and it goes up and then down, and then, so this is like one period of sine, right? This is sine of x, where you start at 0, you start going in the upward direction, then you cycle back down beneath the x-axis, and then at 2 pi, at one full period, you're back up at 0. Cosine starts at 1, it starts at its highest point, and it's coming down at x equals 0. And so this would be one period of cosine. And the reason why this is helpful, in my opinion, is just simply think about what's happening at 0, at the origin for both sine and cosine. Well, at the origin for sine, your height is 0. Your slope, though, is positive. It's positive 1, right? Because we're starting at 0 and we're moving up. We're moving up at basically our steepest point of this sine curve is right at the x-axis. So we're moving up at the steepest slope possible. So what that tells us is that at x equals 0, the slope of sine is positive, and it's as much positive, as big of a number as we can get. Well, if we know that we're either, we're taking the derivative of sine, we know that it's going to turn to something cosine, right? So either cosine x or negative cosine x, because we've already discussed sine and cosine just alternate. You go a sine to a cosine to a sine to a cosine. We're just trying to kind of think about what the sign is. Is it a positive sine, a negative sine, a positive cosine, a negative cosine? So we know if we're taking the derivative of sine, it's going to be either cosine or negative cosine. Well, since the slope at the origin is positive, we need, between cosine and negative cosine, is the y value of that function positive or negative when x is 0? Well, when x is 0 at this y-axis right here, positive cosine is positive at that value. So that tells us the derivative of sine goes to positive cosine. Similarly, if we look at cosine of x, we have at x equals 0, the slope is 0, right? It's at the kind of local maximum of cosine is right at that y-axis. So the slope is 0. So that is what causes either sine or negative sine to be the derivative, because the y value of sine and the y value of negative sine is 0 when x is 0. So the y value of the derivative tells you the slope of the original at that point. So the slope of cosine is 0 when x is 0. That tells you the y value of its derivative has to be 0. So that's why it's either sine or negative sine. Now we want to think about what is the slope as soon as we start kind of moving to the right, as x becomes a small positive number. Well, you see that cosine starts moving down. So its slope is going to be negative as our x becomes slightly bigger than 0. So between sine and negative sine, which of these is going to start moving down in the negative direction as our x becomes slightly positive? Well, we can see right here, positive sine starts by going up and negative sine starts by going down. So that tells us negative sine is going to be the derivative of cosine. And then we can do the same kind of thing with the negative sine and negative cosine. So if we know negative sine has a negative slope at x equals 0, we need to decide if positive cosine or negative cosine is the derivative. Well, between positive cosine and negative cosine, so if this is positive cosine, negative cosine would just be reflecting over the x-axis, flipping it vertically. We can see that we need which of these functions has a negative y value at x equals 0, because sine of x clearly has a negative slope at x equals 0. Well, you can see clearly that negative cosine is the one with a negative y value. So negative cosine x is the derivative of negative sine x. And then we can again do that exact same thing for negative cosine. The slope is 0, but it starts by quickly the slope becomes positive. As we move over to the right just a little bit, the function is moving up, so the slope is positive. So that tells us the derivative is positive sine x, because positive sine x starts moving up in the y direction immediately to the right of x equals 0. So that's kind of how I remember these four functions. They basically just go in a cycle. Sine to cosine, to negative sine to negative cosine, and then in a circle. Back to positive cosine, negative cosine, and so on and so on. So if you can kind of remember the order of those four, that totally works. I like to just quickly think about what these graphs look like when I'm trying to remember the derivative personally, because I like to kind of logic my way through stuff in a rudimentary, very quick, rough way, more than I like to just memorize stuff. However, if you want to just memorize, I would just memorize the order of these four and then just know that you're going to circle as you go through those. Okay, so that is the derivative of sine and cosine. Next, let's get into the other four. The other four I want to kind of discuss together, because I think it's more helpful to kind of think of all four of those derivatives in terms of just purely how to memorize them. I think personally I like to do this logic through what the graphs look like for sine and cosine. I don't think that really works as much for the other four, simply because sine and cosine have much simpler graphs. They're much simpler to remember. The graphs of tangent, secant, cotangent, cosecant, and even more importantly, their derivatives, right? Secant squared, secant tangent, negative cosecant squared, and then negative cosecant cotangent. I couldn't tell you off the top of my head what those graphs look like, and I think most people probably couldn't. So personally, I don't think that is a helpful way to go about these derivatives. I think you'll probably waste a lot of time trying to logic your way through those ones. I would just simply memorize them. And so let's talk briefly about a strategy that you can use to memorize these four derivatives. So the first thing I want to point out, these first two, sine and cosine, their derivatives are much more simple, right? The derivative is just a single trig component, a sine or a cosine, and then you're just remembering if it's positive or negative. For these four, tangent, secant, cotangent, cosecant, their derivatives, first of all, none of the four of them just simply contain a sine or a cosine component. So the derivative of all four of these contain only these four components in their derivative, right? We have a secant, I guess two secant components. Secant times secant is secant squared. Secant and tangent, again, two cosecant components. Cosecant times cosecant is cosecant squared. And then cosecant, cotangent. So think of almost these as like two different buckets. The sine and cosine derivatives only contain sines and cosines. The tangent, secant, cotangent, cosecant derivatives only contain secants, tangents, cosecants, and cotangents in them. So think of them as kind of separate, right? You're not going to go back and forth between the derivative of sine or cosine containing any of these other four trig functions in them, and vice versa. The derivative of tangent or secant or cotangent or cosecant, none of those derivatives are going to contain sines or cosines in them. So that's the first thing I want to point out. The next thing I want to point out is within this tangent, secant, cotangent, cosecant, you can just, hearing me say those over and over, you've probably noticed, two of them start with a C or a co, right? Cotangent, cosecant, and then the other two are just those same words minus the co, prefix, secant and tangent. So you have secant of x, and then cosecant of x, and then you have tangent of x and cotangent of x. Think of these as two little groups within this group of four. The things that start with co are going to go together. The things that start with that C are going to go together. The things that don't start with co are going to go together. So secant and tangent kind of get matched up, and then cosecant and cotangent get matched up together. And just kind of looking at these derivatives here, you can very clearly see that, right? We have our secant and our tangent. The derivative of secant and the derivative of tangent only contains secant and tangent in it. And then similarly, the derivative of cotangent and cosecant only contain cosecant and cotangent in them. So we kind of have, I guess you could kind of break it down into more like three little buckets rather than the bucket of two and the bucket of four. We have three little buckets of two. So the sines and the cosines stay together, the tangents and secants stay together, and then the cotangents and cosecants stay together. So then from there, we do have a very similar pattern between the tangent and the secant derivative, as well as with the cotangent and cosecant derivative. First of all, the first thing I want to point out, the derivative of tangent and secant are both positive. So the pieces that don't have the co are going to be positive, and the things that do have the co, cotangent, cosecant, their derivatives are both negative. So these are both going to have negative derivatives. Okay. The other piece to point out, or the other kind of piece to use to memorize these, is the derivative of the tangent and cotangent. So you can kind of think of, tangent and cotangent going together in a way. The derivative of the tangent and the cotangent is just going to be the other trig function within their little group squared. So the derivative of tangent is just secant squared x. And then the derivative of cotangent of x is going to be cosecant squared x. However, since cotangent has the co, we would then make it negative. Okay, so the derivative of the tan and the cotan is just the other thing in its group squared, and then think about if it's positive or negative. Okay, then the cosecant and secant derivatives is just going to be itself times the cotangent or tangent that's in its group. So the derivative of the secant of x is going to be secant of x times the other thing within its little group, so tan of x. then again over here, the derivative of cosecant of x is going to be cosecant of x times the other thing within its group, cotangent of x. But then again, since the cosecant starts with the co, we then need to make this negative. So negative cosecant x times cotangent. So those are kind of your main components. The sine and cosine go together, the tangent and secant go together, the cotangent and cosecant go together. For the tangent and the cotangent derivative, it's just going to be the other thing in that group squared. For the secant and cosecant derivative, it's just going to be itself times tangent or cotangent, or in other words, itself times the other thing that's in its little group put together. And then just remember, the ones that start with co are going to be negative derivatives. The ones that don't start with co are going to be positive derivatives. So that pretty much summarizes how you can memorize those. So some good tips there that you can use. I hope you found this video helpful. If you did, be sure to like this video and go check out the Elite Guide to AP Calculus AB. It has everything you need to get prepped for the AP test coming up in May. So go check that out, and thanks. I'll see you next time.